Welcome pre-cal students to the homework help video, page 74. Let's go ahead and get started. Numbers 1 through 5. The directions say is the relationship a function. So let's start with number 1. Let's see what we have here, students. Let's see if each input has one output. And here we go. This has one output. 1 has one output. 0 has one output. 1 has one output. And 7 has one output. Your lack of Mr. Earhart is 6. Has 2 arrows. I don't care about that. That's fine. The range does not matter. All that we care about is look at each input. And remember, input is the same thing as domain. We talked about that using words interchangeably. Range is the same thing as output. Okay. Notice each input only has one arrow coming off of it. So yes, this represents a function. Number 3. No, right away you see no. 5 has 2 outputs. 4 has 2 outputs. 3 has 2 outputs. -2 has 2 outputs. No, this does not represent a function. Number 5. No, not at all. The National League is your domain. Look how many out. This is your input. This is your output. Look at this. You've got 3 outputs for 1 input. Here's your input, and you've got 3 outputs. Here's your input. You have 3 outputs. No, this does not represent a function. No. All right, number 7 and 9. We're going to look at table of values and state whether or not they represent a function. So here we go. -2 has only one output. -1 has one output. 0 has one output. 1 has one output. 2 has one output. Yes, this definitely represents a function. Definitely. Alright, number 9. Now be careful on this one. Look guys, number 10 gives you out a 3, and also 10 gives you out what? 15. So right away we do not have a function. The input of 10 gave you out a 3, and it gave you out a 15. Also look at the 7. 7 gave you out a 6, and 7 gave you out a 12. So no, this does not represent a function. Now, students, I got a question for you. What if, just pretend for a second, that I had a 3 right here, and a 6 right here? Then, would I have a function? Of course I would. What did 10 give you out? 3. What did 10 give you out again? 3. So 10 gave you out 3. That's one output. 7 gave you out what? 6. 7 gave you out what number? 6. So 7 only has one output, 6. And 4 only has one output, 9. So in that case, then yes, you would have a function. Okay? But back to the original problem. No, this table of values does not represent a function. Now for number 11, let's see if each ordered pair represents a function. Okay? Here we go. Okay. 0 gives you out a 1. 1 gives you out -2. 2 gives you 0. 3 gives 2. So 0 only has 1. 0 has one output. 1 has one output. 2 has one output. And 3 has one output. We are totally good. Alright? Alright, letter B. 0 has one output. 2 has one output. But hold it right here. Look at this, students. Look carefully. 1 gives you out -2, and 1 gives you out 1. So 1 has 2 outputs, -2 and 1. So this is yes, this is no. Letter C. Yes. 0 has one output, 1 has one output, 2 has one output, 3 has one output. This one here, yes. 0 has one output, 3 has one output, 1 has one output. Okay, there we go. Moving on to number 13. Now students, number 13 can be confusing, but if you'll listen to me, break this down, I will help you, okay? Is the circulation of morning newspapers a function of the year? Now remember I taught you that when you have something like y as a function of x, that means y is by itself. And over here you have your x. In other words, this is your output, and this is your input. Got it? Okay. So, something as a function of something, let's go back, is the circulation of morning newspapers. So circulation, a function of the year. Well, let's see. Y would be your input. This is your year. And circulation is this right here. So this is your input. And this is your output. Now, let's see if each one of these numbers gives you one output, okay? Is the circulation of morning newspapers a function of the year? Well, let's see. In 1991, we only had one output right here. And you're like, no, Mr. Earhart, you're wrong. You had an output right here too. No, the blue dots are the evening paper. This says, is the circulation of morning newspapers a function of the year? So for this year, I have one output. For this input, I have one output. For this input, one output. For this input, one output. For this input here, one output. For this input here, one output. And so on and so forth. Every input has exactly one output. So yes, it is a function. And then of course it says, is the evening newspaper a function of the year? Well, of course it is. Every year, every input gives you one evening newspaper out every year. Okay? So yes to both of these. Yes. Explain your reasoning, because each input has exactly one output. Okay? Moving on to numbers 15 through 27. Okay, let's see if these equations represent y as a function of x. Y as a function of x. Okay, let's get y by itself. Take the square root of both sides. So obviously, students, the answer is no. How do I know that? Well, if you put a number in for x, like 0, you'll get out two answers. Watch. 0 squared is 0. 4 minus 0 is 4. And the square root of 4 would be plus minus 2. So you put in 0, and you got out positive 2, and you got out negative 2. So no, this does not represent y as a function of x. Okay, number 17. Let's get y by itself. Well, students, the answer is obviously yes. I don't care what number you put in for x, you will get out only one output. You can try a million numbers, as many numbers as you would like to try, but every time you put a number in, you will get only one number out. Number 19. Okay, let's get y by itself. Divide everything by 3. Students, I don't care what you put in for x, you're only going to get out one output. Every input that you put in will give you one output. So yes, this represents a function. 21. Okay, get y by itself. Take the square root of both sides. Obviously, the answer is no. This is not a function. Students, please listen to me. It only has to fail one time to not be a function. One time, okay? We'll put, let's see. You can put any number in you want to. Let's put a 2 in. squared is 4. 4 minus 1 is 3. You would get out positive square root of 3 and negative square root of 3 when you put 2 in. So 2 was your input, and these two numbers here are your output. So no, this does not represent a function. Alright, number 23. Now, this is really quite simple. Don't freak out because you see absolute value signs. Just think about it. If you put a number in for x, will you get one output? Of course you will. Nothing has changed at all, students. Absolutely nothing at all. I don't care what number you put in for x. You will only get one output out. So yes, there's nothing to do. Y is already isolated. It's all by itself. So simply put numbers in for x. And every time you put a number in for x, you will get out only one output. Okay? I don't care what number you put in for x. You will get out one output. Alright? Okay, number 25. Alright, now let's see, we have negative y equals 1 minus the absolute value of x. Now let's go through and change all the signs. So y equals negative 1 plus the absolute value of x. Okay? Now students, it's true. Now watch this. It's true if you put a 2 in here for x. Now watch this. It's very true that if you put a 2 in for x, you will get out 1, because the absolute value of 2 is 2, and 2 plus negative 1 is 1. It's true if you put a negative 2 in, you will get out 1. Put a negative 2 in right here. What's the absolute value of negative 2? 2, and 2 minus 1 is 1. But students, listen, that's okay. I don't care if 2 gives you out a 1 and negative 2 gives you out a 1. That doesn't matter to me. Each input has only one output. Listen, every single time you put one number in for x, you're going to get out for the y value one number every single time. So yes, this represents a function. Alright, number 27. Alright, take the square root of y squared. And you get this here. Get y all by itself. Take the square root of both sides. Okay? So, every time you put a number in for x, you will get out two numbers. Let's say I put 1 in for x. If I put 1 in for x, I would get out a positive 1, and I would also get out a negative 1. Okay? So, no, this equation does not represent y as a function of x. It does not. Okay? Alright, moving on to the next problem. 33b, we're going to evaluate v of r at v of 3 halves. So here we go. V of r, I'm going to put 3 halves. So v of 3 halves equals, now everywhere there's an r, I'm going to put 3 halves. So 4 thirds times pi, I'm going to put pi over 1, times 3 halves. Here's my r. I put 3 halves. Okay? And then cubed. So now I have 4 thirds times pi over 1 times 9 over 4. 3 times 3. Oh, I'm sorry, that's not right. 27 over 8. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. Now, let's do some quick cross-canceling. 4 would cancel into 8 2 times. 3 would cancel into 27 9 times. So I have 1 times pi times 9. 1 times 9 times pi. 9 pi. 1 times 1 times 2. 2. So v of 3 halves equals 9 pi over 2. This is your input, and this is your output. Or you could write it like this. 3 halves, comma, 9 pi over 2. Input, output. Okay? Alright, number 34. We're going to substitute y plus 3 in for x, okay? So here we go. Q of y plus 3 equals 1 over x squared. So y plus 3 squared minus 9, okay? Well, next I would have this. Y plus 3 times y plus 3 is y squared, plus 6y, plus 9, and then bring down your negative 9. So lastly, we're almost done now. I would have y over y squared plus 6y. Your 9's would cancel out. So q of y plus 3 equals this here. Okay, this is your input, and this little expression over here is your output. Another way to write it is this, like an ordered pair, y plus 3, comma, 1 over y squared plus 6y. Okay, this is your input, this is your output. Okay, alright, moving on to number 41. Okay, we're going to have three answers. Let's first of all evaluate f of negative 1, okay? Now, where would I put negative 1? This x or this x? Well, let's see. Over here, my domain tells me that for this equation here, my x values have to be greater than 0. That's not negative 1. But for this equation here, my x values are less than 0. Well, negative 1 fits here. So I'm going to put negative 1 right here for this x. So 2 parentheses negative 1 plus 1, negative 2 plus 1, negative 1. So f of negative 1 equals negative 1, or you can say negative 1 comma negative 1. Okay, now let's go ahead and evaluate f of 0. Now x is less than 0, so I cannot use this equation here. However, here x is greater than or equal to 0, so I can definitely use this equation here. Okay, 0 falls right into this domain right here, so I'm going to use this function right here. So 2x plus 2, put a 0 in for x, and we'll get out 2. So f of 0 equals 2, or in other words, 0 comma 2, input output. Okay, f of 2. Well guys, for this part here, your x values have to be less than 0, and that's not 2. However, for this part of the piecewise function here, x is greater than 0. That definitely fits 2. 2 falls right in here, so we're going to use this right here. We're going to evaluate the function at 2, so f of 2 equals 2x, so 2 parentheses 2 plus 2. 2 times 2 is 4, plus 2 is 6, so f of 2 equals 6, or another way to say it is 2 comma 6, okay? Input, output. Alright, not too bad. Okay, moving on, number 49. Numbers 49 through 55. The directions say to find the real values of x such that f of x equals 0. So in other words, you want f of x to equal 0. So where f of x is, we're going to put 0, and then we're going to find the x values that make this true. Okay? Well, this is easy. Bring your 15 over and make it negative. Divide both sides by negative 3. The answer is 5. So what they were asking us is this: what x values make the whole function become 0? 5. So when you put a 5 in, you get out 0. Okay? Alright. Let's try another one. Okay, think this through very carefully, students. We're going to put a 0 in for f of x, okay? Now, I'm going to multiply this whole side here by x minus 2. I'm going to multiply this whole side here by x minus 2. You can do that. And why am I choosing x minus 2? I don't want this denominator. I don't want a fraction. Anything times 0 is 0, so 0 times x minus 2 is 0. Over here, x x squared minus 16 over x minus 2 times x minus 2 over 1. X minus 2 cancels with x minus 2. You're just left with x squared minus 16 over 1, which you really don't need that, so x squared minus 16. Now students, we know how to finish this. Bring the 16 over and make it positive. Take the square root of both sides. The square root of 16 is 4, so positive negative 4. And the square root of x squared is x. So x equals two answers, positive and negative 4. So if I were to ask you, listen to me students, listen carefully, what x values make this function become 0? These two x values right here, positive and negative 4. Alright, number 53. Alright, f of x, put a 0 in. So 0 equals x squared minus 5x plus 4. Now students, this is simple. We're going to factor this. This is a simple trinomial factoring. What two numbers when multiplied together give you 4? When added together give you negative 5? Well, negative 4, negative 1. If you multiply those, you get positive 4. And if you add those, you get negative 5. So 0 equals x minus 4. X minus 1. Now, take this parenthesis, set it equal to 0 and solve, and you'll get 4. Take this parenthesis, set it equal to 0 and solve, and you'll get out 1. So, x equals 4, x equals 1. Okay? So, if I said to you students, what x values make this function become 0, you would say 4 and 1. Alright? Moving on to number 55. Okay, let's put a 0 in. 0 equals, and now we're going to factor this. Pull out what's common in the first two terms. Pull out an x squared. Over here there's nothing common, but there is a negative 1, so we're going to pull out a negative. And that would make this x minus 4. Let's make sure negative times a positive is negative x. Negative times a negative is positive 4. Now, your matching parentheses should be written one time, so write your matching parentheses once. Cross those off, and you're left over with x squared minus, there's a 1 right here, x squared minus 1. So if you take this group here and set it equal to 0 and solve, you'll get 4. Bring the 4 over and make it positive. Here, take this group, set it equal to 0 and solve. Bring your 1 over and make it positive. Take the square root of both sides. The square root of 1 is 1, plus minus. So if I were to say to you, students, which x values make this entire function become zeros? You would say 4, positive 1, and negative 1. There's 3 of them. Okay? Alright, moving on to our last section, 57 and 59. Find the values of x. They want you to find the values of x so that f of x equals g of x. Well, students, if I want f of x to equal g of x, just take this part of f of x, this part of g of x, and set them equal. So x squared equals x plus 2. Now solve this. We notice right away we have a quadratic equation, so you want to move everything over to one side. Now factor. What two numbers multiplied together give you negative 2? When add together give you a negative 1. Well, students, these two numbers here, think about it. If you multiply those, you'll get a negative 2. If you combine those, you'll get a negative 1. So x minus 2, x plus 1 equals 0. Alright? Take this group here, set it equal to 0 and solve, you'll get 2. Take this group here, set it equal to 0 and solve, you'll get negative 1. So, what values make f of x and g of x equal? 2 and negative 1. Let's try another one. What values make these two functions equal? Well, let's set them equal and find out. X cubed minus 3x plus 1 equals x plus 1. Now students, right away I noticed that I have an x cubed, okay? So I want to move everything over to one side. I'm probably going to factor x cubed. Bring the this over, it's going to be a negative x, so negative 4x. Bring the 1 over, bring the x over, it becomes a negative x. Bring the positive 1 over, it becomes a negative 1. Those cancel. So you're left with this. X cubed minus 4x equals 0. Now, how do you factor this? Pull out what's common first. You can pull out 1x from both of these. And now we're all set. Take this group right here, x, set it equal to 0 and solve. X equals 0. Well, there's nothing to solve. Now take this group, set it equal to 0 and solve. Bring the 4 over and make it positive. Take the square root of both sides. The square root of x squared is x, and the square root of 4 will be positive negative 2. There you go. So if I said to you what values make f of x equal g of x, you would say 0, positive 2, negative 2. If you were to graph these two functions, they would intersect at 0, positive 2, negative 2. Pretty cool, okay? Alright, students, that's it. Hope this homework help video has been a help to you. If you have any questions, don't